All right, hello everyone. Today we're going to be talking about the physics of data storage. Um, and yeah, let's get right into it. Um, I want to start to talk about just like the different types of data storage. So let's see if you guys can name a few of these. Feel free to pause the video anytime you want. Just name what these types of data storage are, and I'll have the answer up for you in 10 seconds. All right, well, hopefully you paused. Some of these might be a little old for you guys, but I'm sure you guys got at least a few of these. So we have some very, very old ones on here in the form of cassettes, VHS discs, hard drives, as well as vinyl records. But then we have some more contemporary methods of data storage like CDs, hard drives, SSDs, and SD cards. And we're gonna separate these into a couple different categories. We have like cards or discs, which contain like CDs and vinyl records. We have tapes which contain cassettes and VHS tapes. We have discs, which are like magnetic-based memory, like floppy disks and hard drives. And then we have cards, like SSDs and SD cards. So let's get started by talking about vinyl and records. So how music gets on records. So basically there's this entire machine called the gramophone. And so what it does is you play the sound in the gramophone. The gramophone is hooked up to one of these magnetic pikes um, on like this etching machine for the vinyl record, and it etches in individual like magnetic moments on the vinyl record to then be read by another like audio output device. So this is what etchings look like under an electron microscope, which are very, very fine-tuned. They're very, very small. And these can be read magnetically to be able to produce sound in the form of electrical output, which is super cool. So this is how like some of the older methods of data storage work. They were kind of primitive compared to what they are today, but they're still very, very complicated, very, very scientifically acute. So let's take a look at a video about how cassettes work. So cassettes are one of the forms of tapes. They require magnetic tapes to function. Let's dive right into it. So let's talk about the cassette structure and design. The cassette tape itself is made up of polyester plastic film with a magnetic coating of ferrous oxide. So here we can see um, we have like the two tape reels. We have the tape guide. We have the tape head opening. We have another tape guide, and then we have the 1/8 inch tape, and then the window. So basically, one of the tape reels is unfurled slowly through the tape guide and it's read through the tape head opening. One of the big downsides to these sort of tapes is that they were directional. They could only be played from front to back, and once the coil runs out, once the reel runs out, you would have to manually go back in and rewind the entire reel only to go over the same data over again. So that was one of the bigger downsides for tapes. But fortunately, with future like disc technology, this was worked upon. How music gets on tape, cough cough, tape recorder, cough cough. So when the tape spins, current and magnetic field from an input is sent to the electromagnetic head in the tape recorder, which then interacts with the magnetic domains on the tape and produces a specific pattern. This specific current pattern can then be read by the tape recorder, and then that can be electronically manipulated to produce a sound output. Now let's talk about one of my personal favorites, compact discs, which are also known as CDs. This is what the materials of it look like. The aluminum makes the CD reflective, but there's a couple different layers. So first there's the label, then there's the acrylic, then there's the aluminum, then there's the plastic. And that's what gives it sort of like the reflective properties that are usually associated with CDs. Um, let's quickly talk about different kinds of codes. There's source code and then there's object executable code. Source code is programming code that has not yet been compiled into an executable file. But if you run that through a compiler, something like a computer, object code is compiled code that can be run on any computer with the same CPU architecture. So, CDs are filled with bits of values 1 and 0, and basically the length of those bits determine how long that specific value of 1 and 0 is going to be played for. So this is what a CD looks like under a microscope. You can see like the little bumps and divots in the aluminum layer, and each of those represents a 1 and a 0. And if you read that through using something like a infrared laser reader, similar to the ones that are used in grocery stores, you can actually get an electronic output from it, which can then be rerouted to maybe like your speakers or something similar of the sort to produce sound output. How to read binary on CD. So what the computer does is the electrical signal is sent to the microprocessor using a laser and a sensor. The microprocessor will be able to identify that this is a binary 1. If it is a 0, no electrical signal will be sent to the microprocessor. Microprocessor will assume that this is a binary 0. So this is what a simulation of a CD reading looks like. You guys can go to this link. I'll have it down in the description. But it's just a fun thing to play around with. Finally, let's talk about hard drives and how hard drives work. Here's a YouTube video. And yeah, thank you everyone, and I'll see you in the next video.